In this video, we are going to discuss about a C program to implement first fit memory allocation technique. We know that we have three dynamic storage allocation techniques: first fit, best fit, worst fit. These three techniques are useful in contiguous memory allocation techniques such as MFT, MVT, multi-programming with fixed number of tasks, multi-programming with variable number of tasks. So with the help of these three techniques, first fit, best fit, worst fit, we can load a process in a main memory in these two techniques, MFT and MVT. So now let us see the logic first. So here we have 6 blocks. Block can also be called as partition or fragment or hold. We have 6 blocks. These are the sizes of the blocks. We have 4 processes. These are the sizes of the processes. Now we are implementing a C program for first fit. So with the help of the first fit, we can load a process in main memory. So here the logic is very simple. So here what is the first process size? 357. So we can't, first fit means allocate the first hole that is big enough. Here 357. We can't store 357 in 200 KB of the block. So we can say we have to search for the next block. So 357 is less than or equal to 400. Yes, condition is true. So store P0 process in block 1. So that is the statement here. The process 0 is allocated to 400. So that means we are storing process 0 in this block 1. Okay. Next one is 210. So let us let us check whether 210 can be stored in which block. So 210 is less than or equal to 200. We can't store 210 in 200. Already this 400 is occupied. This 400 block contains this P0 process. Okay. Next, 210 is less than or equal to 600. Yes, condition is true. So we can store this process in this block. Okay. Next one is 468. 468. We can't store 468 in 200 KB of the block. Next to 2 are already occupied. Next to 500. Yes, we can store here. Process 2 is allocated to 500. Next one is 499. Next process size is 499. So here we can't store 499 KB of the process in 200 KB of the block. Next to 3 are already occupied. Next to 300, 250. We can't store 499 KB of the process in 300 or 200. Okay, so that's why here we are displaying the message as process 3 is not allocated. Okay, now let us see the program. After that, we will come to the output one more time. So here these are the inputs here. Bn specifies block number. So how many blocks that we want. P number specifies process number. How many processes that we want. Next one is BS array. It is for reading the size of the each block. BS specifies size of the each block. Next one is PS of 20. So it is for here we have 4 processes in this example. So maximum we can enter 20 processes. Okay, to read the size of the process. Next one is I and J. So these two are loop variables. For repetition purpose, we are using these two. Next to printf enter number of blocks. So for the blocks, B and O is the variable. Next one is we have to enter size of the blocks. For I equal to 0, I less than B and O, I plus plus. Scan of %d comma. For block size, we are using BS of I, BS array. Okay. Next one is printf enter number of processes. So for processes, the variable is P number. Next we have to read the size of the each process. So for I equal to 0, I less than P and O, I plus plus. Next we have to read size of the each process. So scan of %d comma %ps of I. Now let us understand the logic. This is the, here we are using 2 for loops. First for loop is for I equal to 0, I less than B and O, I plus plus. So in the first iteration, I value is 0. That means block number is 0. In the second iteration, block number is 1. Likewise. Next one is for j equal to 0, j less than P and O, j plus plus. Okay. So here the logic is very simple. if PS of j is less than or equal to PS of I. So that means if the size of a process is less than or equal to block. So if you see here, the logic is very, very simple. In the first iteration, here we are checking whether we can accommodate any of these process in 0th block or not. Why? Because in the first iteration we are checking for I is equal to 0. If you see here 357 is less than or equal to 200. So we can't store. Next 210 is less than or equal to 200. We can't store. 468 is less than or equal to 200. We can't store. 499 is less than or equal to 200. We can't store. So that means we can't store any of these processes in the 0th block. So that is the logic here. Okay. Here all these conditions are false. So next what will happen? I++. So in the second iteration we have to search for I is equal to 1. So that means the first block. So 1 is less than or equal to 6 as condition is true. Next j value is 0 only. So 0 less than, how many processes we have? 0 less than 4. So this innermost for loop will be repeated for 4 times for 4 processes. Whether we can store any of these 4 processes in first block or not. So let's check here. Yeah. So what is the first process? 357. So 357 is less than or equal to, in the second iteration what is I value? 1. 357 is less than or equal to 400. Yes, condition is true. So we can store P0 process in the first block. Now there is no need to check for remaining processes. Whether 210 can be stored in 400 or not, 468 can be stored in 400 or not. There is no need to check. Why? Because here each partition should contain only one process only. Each block should contain only one process only. So here 357, this process 0 is already stored in first block. So there is no need to check for these remaining 3 processes. So that's why we have to use a statement called break. If you see here, that is the output here. Process 0 is allocated to 400 and we are storing a larger number called 10,000 here. In the corresponding process we are storing 10,000. Okay, some larger number, larger block number. Here what is the larger block number? 600. So that's why we are storing some larger block number other than 600. We can store 601, 602, 700, 800. We can store any number which is larger than this block number. Okay. So now this process contains 10,000 as well as we are executing the break statement. If you see here the condition is true. So the process percentage d is allocated to percentage d. So percentage d means first percentage d means j. So that means P0 process. Next block, that block. Okay. PS of j equal to 10,000. We are storing some larger, bigger value so that this condition will be false. If this condition is true, then what will happen? Again that process will be stored. But already that PS of 0 is available there. Okay. And execute the break statement. So there is no need to check for the remaining iterations. Okay. Remaining processes. Next what will happen? Next j will become 5. After executing the break, what will happen? The control comes out from the innermost for loop. Next I will become 2. So in the next iteration I value is 2. So now there is no need to check 0th block, first block. Why? Because already those 2 blocks are already compared. Now again we have to start comparison from 0th process. What does P0 contain? P0 previously contains a larger number called 10,000. So 10,000 is less than or equal to 600. Condition is false. Suppose if we didn't store 10,000 here, then what will happen? This 357 will again stored in this block. So that's why we are storing some larger number. So 10,000 is less than or equal to 600. False. Next 210 is less than or equal to 600. Yes, condition is true. So that's why we are displaying that message. Process 1 is allocated to 600. Now we execute the break statement so that the remaining processes won't be checked here. The remaining conditions won't be compared. Next, we need to place 10,000 in this process also, in P1 also. Why? Because P1 process is placed in the main memory. So now this P0 process contains 10,000, P1 process contains 10,000. If we have 10,000 in the process, then it specifies that that process is stored in the main memory. If we have other than 10,000, then it specifies that process is not stored. So now this iteration is over. So next what will happen? I plus plus. So already 200 block is over, 400 block is over, 600 block is over. Next I will become this value, this 3. Now in this iteration we have to set these processes for 500. So now 357, 210. Already these two processes are stored in the main memory. So here the value is 10,000, 10,000. So 10,000 is less than or equal to 500, false. Next here also P1 also contains 10,000. So 10,000 is less than or equal to 500, as condition is false. Next process is 468. 468 is less than or equal to 500. Yes, condition is true. So that means we can store P2 process in third block. So process 2 is allocated to 500. Now again we have to store 10,000 in place of 468 and execute the break statement. So next what will happen? 499. So 499 will be compared with previously 500. Up to this one is over. So now I value will become 4. So 499 is less than or equal to 600. 499 is less than or equal to 300. Condition is false. 499 is less than or equal to 250. So condition is false. So that means process 3 cannot be stored in the main memory. That sufficient main memory space is not available. That's why we are displaying the message as process 3 is not allocated. If you see here, so here, everything is over. Next control comes out from all the for loops. For I equal to 0, for j equal to 0, j less than p and o, j plus plus. If ps of j not equal to 10,000, already ps of 0 contains 10,000, 1 also contains 10,000, 2 also contains 10,000. But ps of 3 doesn't contain 10,000. So ps of 3 contains that process size only. That means 499 only. So 499 is not equal to 10,000. Condition is true. So that's why we will get this message. The process, that percentage d, that id, what is that id? 3. The process 3 is not allocated. So this is the program. Now let us see the program. So this is our program. I will share this program code in the first comment. I will ping the comment. So please go through the first comment. So first we have to read number of blocks, next to size of the blocks, next number of processes, next to size of the each process. This is the logic here. If that process size is less than or equal to block size, then we can store the process in the main memory and set the value to 10,000, break. Next, if ps of j not equal to 10,000, then execute it. Okay, now let us see the output. Enter number of blocks. So here totally we have, how many blocks are there? Here totally we have 6 blocks. So let us enter the number, 6 blocks. Next, 0th block size 200. Next 400. So next 600. Next 500. Next 300. Next 250. Next 350. Next enter number of processes. How many processes we have? 4 process. Size of the first process is 357. Next process is 210. Next one is 468. Next one is 499. 499. If you see here, process 0 is allocated to this 400. Next one, process 1 is allocated to 600. So next one 500. Next process 3 is not allocated. So this is about first fit program. In the next video you will see about best fit. Thank you.